Let's have a look at question 2 now. So they want to run the test of difference between the means in these two towns. That's the hypothesis, that the means are equal versus they are not equal. So it's a two-sided test. Now, regardless of what we said in question A, we assume the variances to be equal, and these are the data that we're working with. Now, let us not ignore question 1, because we'll see that what we did was right. So over here, we said that the variances don't differ significantly, and we claim that we're gonna assume equal variances. That's why they probably want us to assume equal variances, because it's the right assumption. Now, with that said, let's see what the test is. So we're having a t-test where we assume equal variances, and we're running a difference between means. So we're gonna have a t-test where we take the differences between the first group and the second group based on the sample data. So the sample mean of group A minus the sample mean of group B relative to the standard error. And because we assume equal variances, it means we're gonna assume one variance, assume one pooled variance. So for that, we're gonna use here the pooled standard deviation times the square root of 1 over the number of observations in the first group plus 1 over the number of observations in the second group. We have all the data that we need except for the pooled standard deviation, which we're gonna calculate right now. So this pooled standard deviation comes from the pooled variance. Let's calculate the pooled variance. That's going to be equal to the variance of the first group. So that's going to be SA squared times the number of observations in the first group minus 1 plus the variance in the second group SB squared times the number of observations in the second group minus 1 divided by number of observations in A plus number of observations in B minus 2. Now it's a matter of math to substitute all the values. So let's just write that and we'll see what the number is. Let me zoom out, get more space like that, move to the right over here, and we go below. So we're going to have the following. We're going to have this variance, which is 1225. So we write it 1225. Number of observations in A is equal to 10, and it's the same in B. So NB is 10. Now 10 minus 1 is going to be 9, plus we substitute the value over here for B, which is 3050. That's the variance. So we're going to have 3050 times 10 minus 1, which is 9 again, divided by 10 plus 10 minus 2. So 10 plus 10 minus 2 is going to be 20 minus 2, which is 18. Now if we solve the math over here, the pooled variance is going to be equal to 2137.5, but we need our standard deviation in the formula, so we're going to take the square root of this. We're going to take the square root, which is SP square root of the variance, which is going to be the square root of this number, and that value is going to be equal to 46.23. So it's going to be 46.23. With this number in mind, we're going to substitute it back into our formula, and we're going to calculate our t value. So let's see what that value is going to be. The t value is going to be the difference between the sample means, which are 95 minus 130. So we're going to have over here 95 minus 130. We can see it's going to be a negative value. Now the pooled standard deviation is equal to 46.23 times the square root of 1 over the number of observations in the first group, which is 1 over 10. So that's going to be 1 over 10, and 1 over 10 from the second group as well. We take all of it under square root. Now the t value based from that is going to be equal to minus 1.69. That's going to be our value. In the answer key, they say it's positive 1.69. So I don't know, it's either they referred what's going to be the absolute value of the t observation that we see. But in that case, if it's just the regular t value, then it's false. It should be minus 1.69. So that's it. In the next video, we go to part 3, to question 3, and give the conclusion.